In this question, we throw an object upwards with 20 meters per second from a cliff. The object will go up and at some point start falling down again. We want to know when is it at minus 25 meters, when at plus 25 meters, when at 0 meters, when rising at 50 meters per second, and when falling at 50 meters per second. Now, to start with, I did draw a little VT diagram. I know my initial velocity, which was 20 meters per second, and I know that I went down by 10 meters per second in 1 second. That's my acceleration, that gives me the slope. So from here actually I would know that at 2 seconds my velocity is 0, which would mean in 2 seconds I'm actually up here. Now let's look at the question that are asked. Actually the easiest one to answer right now is number D. So let's start with number D. When is it at 15 meters per second? Just from looking at the graph, you could say the answer must be 0.5 seconds, somewhere between 0 and 1 second, because at 1 second we are at 10 meters per second. How can we calculate it? Use the formula change in velocity is acceleration times change in time. Now my change in velocity to get from 20 meters per second to 15 meters per second is to slow down by minus 5 meters per second, which is equal to 10 meters per second square times the time we don't know. Now let's divide by meters, multiply by second square, so end up having seconds here. Then we divide by actually minus 10 because the acceleration goes down, and so I end up with 0.5 seconds is my change in time. So D is done. Number E. When is it falling at minus 15 meters per second? So here we have minus 10, minus 20. So we know from the graph that it probably is at 3.5 seconds. Now let's do the equation again. Change in velocity is a change in time. Therefore, from plus 20 going to minus 15, we have minus 35 meters per second is equal to minus 10 meters per second square times the change in time. Divide by meters and multiply by second squares. I divide by 10 and the negatives go away, therefore my delta t is 3.5 seconds, which corresponds on what we've seen in the graph. So E is done. Now let's look at number B. When are we at 25 meters? Well, 25 meters must be somewhere when you're going up, right? So our highest point where we found out will be at 2 seconds. So let's calculate how high we are at that point. So we look at the area on the curve here. So B, highest point. We have our change in position must be half of the big square because we have a triangle. So we would have 1 half of 20 meters per second times 2 seconds, which gives 20 meters. That was actually stupid doing that in the calculator, because you could just take the 2 away, seconds away, and you have to result right. So actually the highest point is 20 meters. Therefore our object will never get up to plus 25 meters. So answer 25 meters are never reached. Number B is done. Let's look at number C. When are we back at the same altitude that we started with? Now we went up 20 meters. To be back at the same altitude again, we need to have the same area that we had here, above the curve, under the curve. And if you look at it, you will see actually that these two parts are symmetrical. Therefore, if it took us 2 seconds to get to the highest point, it will take another 2 seconds to get back down, and the result is at 4 seconds. Where my A1 is equal to A2.